So recently I had a bit of a mishap in the shed where I was doing some wiring and I accidentally put 24 volts into the 12 volt circuit and destroyed the lights in my shed. So I've got these two sets of these LED lights, and I don't think they're as bright as the lights I had, but I can connect them up just now. And they take 13.3 volts, 0.2 amps, 2.6 watts. So they'll not use that much electricity at all. I think my old lights, both of them together, used over 10 watts anyway. But these ones should save quite a bit of electricity, especially in the winter. So I'll get those mounted. And I've got these current sensors here, Hall Effect ones. They are the ACS 758 current sensors. This is a LCB 100B version, which means it's bi-directional. It can measure negative currents too. And this one's a unidirectional version. And the reason I've got one that just goes one way is because it's just for simply to get better measurement accuracy, better resolution, and it's kind of easier to program for as well. I'll be making an Arduino battery management system, so I needed logic level MOSFETs to drive power into resistors. So basically the battery management system will consist of an Arduino Pro Mini, and there'll be one Pro Mini to each cell, but I have an issue with getting batteries just now. The source I have in Germany, getting any sense out of them is just like drawing teeth. I can't get anywhere with them. Their communication is very poor, and they're obviously not wanting to make any business at all. That's InnoPower, a German distributor, and they're just not updating the prices correctly on their website, and the shipping costs are all wrong, and it's not charging VAT, and it's just been a nightmare. So basically what we'll have is the Arduino Pro Mini, a MOSFET and a resistor. This is a 10 watt 3.9 ohm resistor, and that should be able to keep them in balance. That's the MOSFETs there that I'm going to use. I don't know if they'll work or not, but simply all I can do is maybe connect two of these resistors in parallel and have even more current. And this Arduino is a 5 volt version. I might need the 3 volt version to run properly off the batteries. And all we'll be using is the internal voltage reference, just to get an accurate reading. And when simply all that will happen is when the voltage is above a certain threshold, it'll just activate the MOSFET and discharge into the resistor until it falls again. This here is an electric bike controller. I need another one for the DC refrigeration compressor that I've got, because I had to take the controller off that and use it on my generator starter. So I might use this one either on the compressor or the starter, I'm not sure. But this will need to be modified to remove its low voltage cutoff, so I can run it on any voltage. And plus, I'm going to figure out a way to control this with an Arduino so it simply can respond to temperature. But as for the lights, I reckon I could turn the voltage up a bit and maybe run these on about 14.2 volts. My 12 volt supply system in the shed is fully adjustable anyway, so I should be able to do that.